There are a couple of different ways to solve a rational equation. The first way you've already learned. Using a proportion is one way to solve rational equations. When two rational equations are equal, they create a proportion. Then you can cross multiply and solve. You did this in an earlier concept. In this concept, you're going to learn a new way to solve rational equations. You're going to learn how to clear the denominator. Sometimes a rational equation has many different parts to it. When this happens, you can't solve it by using a proportion. You have to use the second method here. You have to clear the denominator. Let's take a look at an example. 6x minus 2 over x equals 8. Now we need to clear this x. It's a denominator that we need to get rid of. We can do that by multiplying both sides by x. On the left side, the x's cancel, leaving us with 6x minus 2 equals, on the right side, 8 times x, which is 8x. Now we can subtract 6x from both sides, just like we would in solving a linear equation. These cancel, leaving us with negative 2 equals 2x. We divide both sides by 2, and x is equal to negative 1. This is our solution. Let's look at another one. 4x minus 2 over x plus 1 equals 10. Now our denominator is a bit more complicated. We have x plus 1 as a denominator. However, we can clear that denominator in the same way we did on the previous screen. We can multiply both sides by x plus 1. On the left side of the equation, the x plus 1's cancel, leaving us with 4x minus 2. And on the right side, we have 10 times x plus 1. Now eventually we want to solve this equation for x. However, we must use the distributive property on the right side to get rid of the parentheses. Bring down the 4x minus 2 equals 10 times x, which is 10x, plus 10. Now we can solve it like a multi-step equation. We can subtract 10x on this side and 10x on this side, leaving us with negative 6x minus 2 equals 10. Add 2 here, and we have negative 6x equals 12. Now we divide both sides by negative 6, and x is equal to negative 2. Our problem has been solved, and our work is complete.